So this new home MemoryCraft 4000 machine, the presenting problem is that it overloads and the machine shuts off. Um, the reason that this machine would do that is because as it turns freely, everything is moving, and if something binds in there, for instance, maybe it goes through something too thick and the needle can't penetrate and the machine is pushing really hard to go through, it will protect the circuit from overloading and burning something out, like a stepper motor or the motor itself, the DC motor, or damage the circuit board. This machine can overload for a number of reasons. One, like I said, would be going through something really thick, or perhaps something gets stuck, like a piece, something breaks off maybe, which is highly unlikely, but maybe something breaks, or the needle bar in the bushing get worn out and it generates a lot of heat from the steel in the aluminum needle frame, maybe starts generating a lot of heat from friction and seizes up. It will prevent the machine from turning, which will trigger the overload. The same thing can happen up on the upper shaft. The upper shaft here, this piece here goes through a bushing on this side, and it goes through a bushing inside of there. And if that is failing, it will heat up and cause friction. The friction will cause the heat, and it will bind and make the machine very hard to turn and will trigger the overload. And the exact same thing goes for the shaft on the bottom. It has a bushing here, a bushing there. Generally speaking, this bushing is the one that will fail if one ever fails. I inspected this bushing. It's perfect. It appears to be perfect. This bushing over here is fine. The upper bushing is fine. It's not leaking. I can usually tell right away if that's going to be this bushing. I've never seen one fail. I've seen upper bushings on the right, upper and lower bushings fail before, but this one it actually turns beautifully. I ran it at top speed for about more than 5 minutes. I also checked a lot of different things. I checked the idler pulleys on the belts. This is the motor belt and the timing belt. They move beautifully. The clutch for the hand wheel is working beautifully. Nothing's binding. This piece with the hand wheel connects to, that is working fine. I looked at the needle bar frame, the bushings, the take-up crank. All of the links of the take-up are moving beautifully. Nothing's loose. Nothing is triggering anything. I also looked at the hook is moving beautifully. I checked the hook timing. It's perfect. I checked the feed timing from the feed timing gear. The feed timing is set properly. The bobbin case is fitting beautifully. It has no damage, no wear. So that's not creating anything that can cause the machine to overload. The needle plate is going in. The feed dogs are not rubbing on the needle plate. They're going okay. I think that the feed dog height needs to be either adjusted. I think it needs to be adjusted a little bit. This is the feed lifting cam. It doesn't appear to be terribly worn. Whoops, moved my camera there. The feed lifting cam doesn't appear to be worn enough to warrant replacing that, because that's a big job, replacing the lower shaft and the there is significant wear on this cam for the feed. but it's still in good shape and it's not creating a bind. So another thing that I did was I ran it at a higher speed. Let's take this off. Another test that I do on that. The place that she brought it to before told her that this was a bad foot control. Well, it actually works fine. There's nothing wrong with this. These foot controls are actually quite good. They almost never fail. The one that they sold her is this one. It's a Janome part, and it's a good foot control, but and it works just fine, but this one is generally better. There's nothing wrong with this one. I don't see any reason to change that out. So another test that I can do to see if a machine's going to overload is I can run it at any speed. The beautiful thing about these machines is they have DC motors, meaning direct current rather than a alternating current. An alternating current motor, when it goes slow, the foot control feeds a small amount of electricity to the motor, which makes it run slow, and then it feeds it more electricity to make it go faster and faster until it reaches its maximum speed at maximum voltage, 110 or 115. This is a DC motor, which means it delivers maximum piercing power with any speed. So a machine like this, the test that I generally do with these is to run it and then to grab the hand wheel and try to stop it. But when you do that, if you try it too much, it will overload. However, the machine does not overload. I have not been able to get it to overload. It takes quite a bit to do that. So, frankly, I think that the reason it was overloading is because the machine was encountering something that was too difficult for the machine to pierce through, or there was some kind of a bind happening due to the sewing project itself. That's the only thing that I can find. I've gone through everything, and one thing about these machines is with the circuit protection is that it's not just a fuse that blows. It's actually it's not a fuse that blows. It's inside. There's an internal thing that will shut off, and then if you wait for 5 minutes or about 5 minutes, it will reset, and then you can run it again. And I think it's a thermal fuse, and that's the way those work. So I don't justify going into the circuit board, taking this thing all apart and going into the circuit board to replace that. It's not failing. So that's the synopsis on this Memory Craft 4000.